Hey everyone, welcome back to the class, and today we'll learn something interesting. We'll try to prove root 2 is irrational. Okay, so this is our question today. We'll try to prove this is a kind of we can say theorem. So under theorem also you can study, no problem. So we'll prove root 2 is irrational. And now the thing is that we know that root 2 is irrational. If you're going to divide in long division method, you will get the 1.414 and number will be keep coming on. But we'll try to prove one. We know that root 2 is irrational, but how to prove this one? There is only there's the way. This is called method of contradiction, and method of contradiction means that we'll say the opposite thing. Suppose if you're a boy, then we can say you are a girl. No, you are not a boy, you are a girl. The same way, we know that root 2 is irrational, so we'll prove this one. We can just say theorem. We'll prove it as a proof. Okay, in the proof we will say, let us assume root 2 be rational. We will say opposite of it, because in this way only we can say, because we know that root 2 is irrational, so we'll say opposite thing. This is a rational. Okay, if let us assume root 2 is a rational number, then it will be of the form, let's suppose P by Q also you can say, A by B also you can say, no problem, A by B, where A, B are integer. Okay, I hope all of you have clear concept about integer. And remember, and B, as we know that Q can't be 0, in the same way here we are not using Q, so we will say B doesn't equal to 0. The below one denominator can't be 0. Okay, so now again let A and B, okay, A and B have no common factor, other than 1. What it means that if I say what it means for example, let us use this mouse. Okay, what do you mean by that no common factor? It means that, so for example, if I write 8 by 4, as you can see, these are common factor. We can cut it. 4 1s are 4 and 4 2s are. So still we are getting 2 by 1. We can write 2, no problem. But they are saying no common factor. So whenever we are taking in this way, like for example 3 by 4, I'm just showing you numbers so that you can understand. You can see we can't cut anything. We can't cut 3 and 4 because 3 is not in 4 table and 4 is not in 3 table. So in this line we can say A by B means this number only, A by B have no common factor other than 1. Only 1. Okay, you can cut 3 1s are 3, 4 1s are 4. So we will not cut exactly, we know that, but the common thing between two of them is 1. Okay, so that's what we have written over here. Okay, so I hope you have understood this one. So now let's remove this. Okay, so not common factor other than 1. Therefore what we can say, therefore root 2, okay, is equal to, let's suppose A by B, because we said now this is a rational number. You can see in our proof we said this is a rational number, so we said okay, if this is a rational, then we'll say this both of them are equal, where A and B are co-primes. Okay, co-primes. As co-prime means when there is no common factor other than 1, that means the co-prime. Okay, integer. So what we need to do, we'll try to remove this square on a squaring. Okay, on a squaring both sides we get, if you square this both, okay, on a squaring both side, we will get, as you can see, root over 2 was there, okay, so we'll square, and a by b whole square, okay. So now we know root over 2 is what? Root over 2, we can remove the square by just applying, okay. If you have still problem, then I can root over means power half, okay. If you see, power half means root, outside is 2, so this 2 to cancel up, so root over 2 will be your 2, and as you can see, a square and b, okay, so obviously we'll be using a square by b square. Do you understood this? If you have a still doubt regarding any of this thing, then you can comment down, okay. So what we can do that, okay, we can send this side off, 2b square is equal to a square, let's suppose equation number 1, okay. Now if you see properly, okay, let me explain one more thing. This is a theorem. If you have studied that theorem, then you may understand. So now the thing is that b is this side, we can send this 2 downside. So if you see, 2 is dividing a square, okay, and if 2 is dividing a square, then 2 will divide a also, because you don't have to write this one, just for explanation, because in that theorem you may have learned about this thing. If you have not learned, then you can see, because you see, just for example, if there is 2 square, okay, and below side we have 2, if this 2 can divide 2 square, which is 4 by 2, 2 1s are 2 and 2 2s are, it can divide, yes or no? So in the same way, it can divide 2 by 2 also, because it doesn't matter in what sense you are giving, okay, 2 1s are 2 and 2 1s are 2, so it will divide that also. I hope, do you understood what I said? If you have doubt, then you can ask again. Okay, again this one. Okay, now it will be removed. So what it says that, I can write here, 2 divides a square. If 2 divides a square, then 2 will divide a also, okay. So this was from your theorem 1. We are using NCERT book, okay, so you can use from theorem 1. If you don't have, then you can just leave it from theorem 1, okay. This is theorem. So if we have done, if you have understood up to this, then okay, we'll go to the next. Now then a, we'll just replace some other later, then a can be written as, let's suppose some value instead of this a, okay, we'll write something like, instead of a, we'll write, you see, a is an integer, it doesn't matter what, so we are just pointing, like we used to say, find the x, so you can take whatever you want. So instead of x, you can take any other letter also. So we are just we can take a is treated as a what? It's an integer. So integer, it can be anything. So we are just written as 2m. Okay, we are just writing as a 2m, where m is integer. Of course, m is integer. M is integer. I'm just writing j. Okay, z. So on putting a is equal to 2m in equation 1. Okay, we'll be putting in equation 1. We'll put in this equation in the value of a. Okay, now what will happen, you see, 2b square already, which is there, instead of a we'll write 2m square. Okay, so in this 2m square, if you see properly, 2b square is equal to 2m square will be 2 square is 4 and 4 will be m square will be this. If you see b square, this 2 will go downside. If you send this one downside by 2, it will cut 2 1s are 2 and 2 2s are. So we can say b square is equal to 2m square. Okay. So here you can see, if you send this one to this side, just for example, b square, you don't have to write, 2 will come this side, it will be m square, yes or no? So now this is not your part of answer, just for explanation, 2 is coming downside. So I can say here that, so 2 divides b square. Okay, if 2 divides b square, then 2 will divide b also, yes or no? 2 divides b. Okay, if this is dividing this, we have already explained about this one. So if this one 2 is dividing b square, then of course this will divide b also, isn't it? So the thing is, from theorem 1 we can write. Okay, no problem. From theorem 1. Okay, you don't have to write this one. Okay, from theorem 1. Now thus 2 is a common factor of 2 is the common factor of a and b. Why I am saying common factor? You see here 2 is dividing this b square also, and 2 divides b also. Just a moment ago you can see 2 was dividing a also, and 2 was dividing a, isn't it? 2 was dividing a square and 2 was dividing a. So if you see what we have taken in earlier, you can see already we said that AB, where AB are co-prime. Co-prime means there is no common thing. We already said in the beginning that let AB have no common factor other than 1. So if AB is there, means if there is no common factor, then in this video you can see a2 is dividing a square also, 2 is dividing b also. Okay, so from where this 2 came out. So this is a contradiction. Actually this 2 should not be there, but this arises a contradiction. So for this reason we can say that root 2 is irrational number. So okay, let us write this one. Thus 2 is a common factor of this one, but this contradicts the fact that a and b have no common factor other than 1. We already said in the beginning. So this contradiction, this contradiction arises by assuming that root 2 is rational, yes or no? In the beginning we took the first thing is that this contradiction, the whole thing arises just because of this, because we said root 2 is a rational number, but in the reality we know that root 2 is a irrational number, isn't it? But we have taken the wrong thing, so we got the whole wrong thing. Okay, so this is actually getting up to, so root 2 is rational number. Okay, now what we can say is that hence root 2 is irrational. Okay, we can say root 2 is irrational, hence proved.